The Zwicky transient facility has taken its first image covering an area equivalent to 247 full moons in a single shot. This beginning is part of an ongoing sea change in astronomy. Pictures have long served as a foundation of astronomy, but very soon astronomers will be turning to videos. Humans have always known that the seemingly eternal sky changes from night to night. Aborigines even incorporated such changes into the mythology, but for the most part studying celestial transients has required a great deal of patience or a willingness to trawl the archives. Only in the 21st century, in the era of big data, has astronomy had the capability to truly step into the time domain. The Zwicky transient facility ZTF is a part of that sea change. It just took the first image of many, a 47-degree field of view equivalent to the area of 247 full moons, captured in 24,000 by 24,000 pixels. The scene holds a chunk of Orion, showing the Orion, Flame, and Horsehead nebulae. This image precedes the facility's science phase, which is set to begin in February 2018 and complete by 2020. ZTF took this first light image on November 1, 2017, after being installed at the 48-inch Samuel Oskin telescope at Palomar Observatory. The full-resolution version is more than 24,000 pixels by 24,000 pixels. The image contains the Horsehead, Flame, and Orion nebulae. Computers searching these images for transient, or variable, events are trained to automatically recognize and ignore non-astronomical sources, such as the vertical blooming lines seen here. Caltech Optical Observatories. The first light image from ZTF is shown here inset within the Orion constellation. Caltech Optical Observatories. The ZTF is the sequel to the Palomar Transient Factory PTF, which employed 3 telescopes: the automated 48-inch Samuel Oskin telescope, the automated 60-inch telescope, and the 200-inch Hale telescope, to triage the night sky. The Oskin telescope acted as the discovery engine, then the 60-inch telescope followed up to help identify the sources. The Hale telescope, as well as others, provided further detail for those objects meriting in-depth investigation. Named after astronomer Fritz Zwicky, the ZTF is also installed on the Oskin telescope, but with 2 big changes. The camera it uses surveys 7 times the area of the PTF camera, enabling it to capture more sky at once. The electronics have improved too. While it took 40 seconds to read an image from the PTF camera, it takes only 10 seconds to read the bigger image taken by ZTF, while the fast-slewing telescope readies for the next image. Principal electronics engineer for Palomar Observatory, Roger Smith, describes how Palomar's 48-inch telescope was originally built and then adapted for use in the Zwicky transient facility in this video from Caltech. As a result of these modifications, ZTF is about 12 times faster than PTF, in fact, scanning at its full speed of 3,750 square degrees per hour, it could cover the entire sky in a single good night. But, explains project lead Srinivas Kulkarni Caltech, that's not what astronomers want. The issue is cadence. Catching a supernova just after it has exploded, for example, would require repeated observations every couple hours. If the telescope scans only once a day, astronomers would miss those crucial first moments of eruption. Cadence is something that gets people very emotionally spun up, Kulkarni says. Fritz Zwicky had the 18-inch Schmidt telescope at Palomar Observatory in the 1930s. Edison R. Hodge photograph collection. Caltech archives. So the ZTF team compromised. The facility will scan the full sky every 3 nights. It will spend the other 2/3 of its time on 2 other projects. One project will look away from the plane of the Milky Way, hoping to catch distant supernovae, gas-guzzling black holes, and other ephemeral events occurring outside our galaxy. The other project will look directly at the galactic plane, dense with stars. It's technically hard to look at so many stars and extract signals. Kulkarni adds, but if we're watching, say, tens of millions of stars a night, something will be happening. Any given image the ZTF takes could hold more than 100,000 stars and galaxies, and the observatory will be collecting 4 terabytes of data every night. Amidst all those sources of light, what will astronomers, or the computers they train, be looking for? The answer's a legion. PTF has already caught a star just 11 hours after it exploded in a type Iowa supernova, and ZTF has the chance of catching such an event even sooner. Dennis Bodwitz, University of Maryland, estimates that ZTF will sweep up 30 to 50 comets every time it scans the whole night sky, giving amateur astronomers a good run for the money. Near-Earth asteroids are another target. Suvi Ghazari, also at University of Maryland, hopes to catch a black hole as it catches and tears apart a star, an act known as a tidal disruption event. Astronomers could watch as the star's gas forms an accretion disk around the black hole, which could even power a jet. ZTF will also serve as a crucial follow-up instrument, pinpointing the origins of sources discovered by LIGO and Virgo, the IceCube Neutrino Observatory, and Fermi's Gamma Ray telescope. ZTF will chart variable stars such as Cepheids and R-Lyrae that are crucial to mapping out the structure of our galaxy. Looking ahead, ZTF is a stepping stone to an even bigger project, the Large Synoptic Survey Telescope. Scanning at 10 times the rate of the ZTF, LSST is set to make a 10-year movie of the night sky starting in 2023. Read more about how machine learning is tackling astronomy's big data in the December 2017 issue of Sky Telescope.